Hey guys, this is the TS.4 Reteach. So again, if you need to redo the standard, watch this video, follow along with the notes, and then you can take it, you can ask me for the code when you're finished with this video. This standard was over volume and surface area, the last thing we did in our geometry class. The beautiful thing about volume and surface area, we literally have formulas for majority of everything. So we should have this paper on our desk. The interim assessment reference sheet. We have our, I can't really write on this, but we have surface areas over here on the bottom right, surface areas of formulas. So we've got the formulas for majority of the shapes we need. And then the bottom row where it says V equals, all that is our volume. We've got formulas for majority of everything we need, which is beautiful. So let's kind of go through these problems. If you do not have this, pause the video, raise your hand, and I will give you one as well. You should have one for your retakes as well. Okay? Let's kind of go back to the questions. Number one is asking, a drill press is used to remove a cone of steel from a solid cylinder as shown below. Okay, what's the volume of steel that remains after the cone is removed? Okay, so we're talking about the volume of the steel, so from the cylinder after the cone has been removed. Well, anytime I think about the word remove, I think of I have a whole thing and I'm removing it from something else. So if I had 10 cookies and I'm removing them from the room, I'm eating them, I'm losing cookies. I'm losing that number. Well, the operation for losing something is subtraction. We're talking about volume, so I need to find the volume of the cylinder and the volume of the cone and subtract them. That was the last lesson we talked about actually in our unit, was composition of 3D dimensions. If we see objects that are inside each other, we probably should be subtracting them because I want to find the volume of all the other stuff, basically. I don't want to find the volume that's taken out. I want to find the volume of the other stuff. So we need to subtract those two volumes together. Okay, well, let's go back to that formula sheet. We're talking about volume, so I should be on the back side. That surface area. Volume is down here. Well, my cylinder is that second one over. We see it's a cylinder shape. It's volume equals pi r squared times height. Let's write that over here. Cylinder equals, well, the volume of a cylinder equals pi r squared times height. And then the volume of a cone, let's kind of go back to that, is 1/3 times pi r squared times height. We also know that this 1/3 can also be divided by 3. It's the same thing. We were learning it in class as a division, which is the exact same thing, right? 1 is in front of the pi, divided by 3. Okay, well, let's kind of solve what's going to be happening over here. Well, the cylinder, I see that they give me a diameter of 6. Well, I don't want the diameter, I want the radius. So we know what we have to do with the diameter is divided by 2. So the diameter is 6, then the radius has to be 3. Taking the 6 divided by 2, that gives us 3. So let's kind of plug in everything. Pi times 3 squared. And then my height of the cylinder is the whole thing, 12. So I see all my answers have pi random. So let's not multiply pi with our answers. Let's just multiply the numbers together. Well, 3 times 3 is 9. 9 times 12 is 108 pi. There you go. Again, it's still multiplication within there. We're just not plugging in that pi button. We're just doing that simple math we can do in our head. Same thing with our cone. Oops, I forgot to put a radius there. That's my fault. Same thing with our cone. It's actually the same numerator. As you can see, it's the pi r squared, except for a cone, we're going to divide by 3. Okay, same formula, but divide by 3. Let's check to see what all those pieces are for the cone itself. Okay, so pi our the radius is the same thing as our cylinder. But our height of the cone is only 3 centimeters, so we just have to multiply by 3. Divided by 3. Again, same idea. Let's keep pi outside of it, so let's just multiply and divide the numbers together. 3 times 3 is 9. 9 times 3 is 27. But I've got to divide 27 by 3, which 27 divided by 3 is 9, we just said. Again, you can throw that into the calculator as well, too. So the cylinder, 108 times pi, and then cone is 9 pi. All we have to do is subtract them, which is super nice. So let's do that off to the side. 108 minus 9 pi. Well, I can leave that as a pi. We don't need to worry about that. We can just plug in 108 minus 9. Well, 108 minus 9 should give me 99. We can plug these into the calculator. And obviously, we want our answer to have pi in it. So there you go. Pretty simple. So we're going to use those two formulas, actually. This cylinder formula and the cone formula for number 2. So number 2 says a cylinder and a cone shown below has the same height and same radius. Okay. The volume of a cylinder, so the volume of this guy, the first one, is 48 pi. What is the volume of the cone? So we see that the cylinder's formula is pi r squared times height, and the cone is pi r squared times height divided by 3. We talked about this in class. The cylinder has the same formula as a cone, but we said that a cone is a third of a cylinder. I talked about if I filled that cone up with water, it would take this cone 3 times to fill up that whole radius out of the same amount of water. It would take this cone 3 times to fill it up completely and pour it in the cylinder to fill that one up. So if I want to know how much volume is in the cone, well, it's just a third of the cylinder. So let's take this 48 pi and divide it by 3. That's the best thing about this, is a cylinder and a cone have a big relationship to each other, except a cone is always a third of a whole cylinder. So just divide the volume of a cylinder by 3, and that'll give us our our volume of the cone. So this is just kind of some long division, but you can throw this in the calculator as well, which will be super helpful. And there we go. If we just put in 48 divided by 3 in Desmos, we would have gotten 16 as well. And our answer needs to have pi in it. There you go. Let's do number 3. Well, holy moly, there's another cone. But let's see what it's asking, right? It says find the surface area of the cone and round to the nearest hundredth. So this one we actually need to put pi in our answer. Let's go back to that formula sheet because I'm not doing volume. My surface area for a cone is SA, surface area, equals pi r squared. Oop, I can zoom. There we go. Surface area, that's SA, pi r squared plus pi r times that lateral height. Remember, lateral height sounds like a ladder, so it should be that length that's leaning, right? So surface area, that's what I'm solving for, pi r squared plus pi r times the lateral height. Perfect. We got everything we need. Our radius is the part of the circle, half of the diameter, and that 17.9 is the lateral height. It looks like it's on the side. It's like a ladder. It's leaning up against it. So pi times 8 squared plus pi times 8, and then my lateral height is 17.9. So if we plug that exactly into the calculator, what do we get? Sorry, I'm just plugging that in right now for myself. I believe we should get that 650.94 centimeters squared since we're talking about area. So the one that would match that is our B. Again, just plug this exact thing into our Desmos, a handheld calculator, whatever you want to use. We'll get the exact same answer. Okay, beautiful. Last one, number 4. We are still talking about surface area, but this shape is a prism. Remember, a prism has 2 congruent bases. It's also a rectangular prism. That's a big indicator right there. So let's kind of go back to that formula sheet. For surface area, a prism is the surface area equals 2 times the, that was not supposed to happen. 2 times the area of the base, that's the capital B, plus the perimeter times the height of the shape. So, again, let's write that down. Well, we got to find those 3 variables. B is the area of the base, so let's just take the base. Area of a rectangle is always length times width. That's on the back of that reference sheet as well, which is super nice. You can see that right here. Rectangle, length times width. Uh, 20 times 10. 200. Perimeter is adding up all the sides. So I know I have a 20 over here, a 10 over there. So 20 plus 20 plus 10 plus 10. 40, 50, 60. And then the height is the distance between our 2 congruent bases. So I know I have a congruent base up here. So the height is what's between those 2 rectangles, which is our 7. So let's plug in all those numbers into the formula. The 2 times the area of the base, which was 200. The perimeter was 60, and our height was 7. So all we gotta do, plug this exactly into the calculator, and we should get 820 meters squared, which is D. Beautiful. All right, guys, so if you have any questions, let me know, but at this time, you should have more notes than me, or maybe the same amount, and then just raise your hand, I'll get you the code. Thanks, guys.